Are you a front-end developer using Redux? Are you tired of spending countless hours writing the same boilerplate actions and reducers over and over, consuming a vast amount of time and resources that could be spent on the core business logic of your next multi-million-dollar company if you're Mark Zuckerberg, or more likely, a failed startup if you're everyone else? Introducing FlowScript, a DSL for Redux CodeGen. With FlowScript, you can generate the most common Redux use cases used by your application, allowing you to fill in the remaining business logic that needs to be completed. FlowScript uses the concepts of flows, actions, and action classes, which encapsulate generic use cases of Redux. Each flow in a FlowScript program allows a reducer to be generated. Actions and their associated classes are responsible for generating actions and services that make up your application. Composing these actions together into flows allows you to create reducers, which make up your Redux state. We started with a preliminary language design, but upon realizing that this would be incredibly cumbersome to type, and that nearly the entire English language was reserved, we quickly rejected this design, and we opted for something that not only was a bit more concise, but a bit more like JavaScript and TypeScript, which our users would be familiar with because they are Redux users. So once we had our language design, we went to creating documentation, including the FlowScript user study task. We got our good friend and fellow classmate Michael to help us. Well, welcome, Michael. This is our user study for FlowScript.
So I think the syntax looks similar to JavaScript, which is good because I'm already familiar with JavaScript. Okay, so this syntax, my action greater equal, the greater and greater, my flow name, my first field. It's a bit confusing here.
Addressing the feedback from Michael, we made several key changes to our language. Though Michael was confused by the modifies syntax, we decided ultimately not to change this part of the grammar for a couple reasons. One is because one of the things that Michael suggested to replace it was using an equal sign. But this equal sign already had semantic meaning in other parts of our language. The way we construct our AST is first by having a tokenizer, and then that is passed into our parser. So rather than using a pattern in class where each of our AST nodes having a parse evaluate method just has this accept AST visitor, and then the visitors allow us to implement our entire code in one file. So the CodeGen visitor takes our AST that is now type checked and produces Redux code. If I say npm test, the tests will appear in the console, and bam. After implementing our language, we decided to take a second user study. While Michael gave us feedback on the syntax and semantics of our language, this participant gave us feedback on the code generation. FlowScript, a DSL for Redux CodeGen.